So by now in your study of quadratic equations, you've learned how to take an equation like this, plug in values of x to get in certain corresponding values of y to create points. Like for instance, negative 3 comma 0 is a point, or 0 comma negative 3, etc., for this equation. But in this video, what we're going to be doing is actually the opposite. We're going to be turning it around and taking points to begin with and see if we can create the equation that created those points. So if you want to find out how that all works, stick around. Let's get it on. In order to learn how to work backwards and go from points to the equation, let's take a look at how to actually do it where you take an equation and find a couple of points. So by now you should have learned how to take an equation like this in what we call standard form. Let me go ahead and write standard right here. And what you've learned is how to factor and use the zero product property. So what you would do is you would take this y and you would turn it into 0, because anytime we have an x-intercept, y is equal to 0. You would factor. And once you found your two factors, in this case x minus 4 and x plus 2, you set each of them equal to 0 and solve for x. And by the way, x equals 4 and x equals negative 2, those are called the roots. And then from there, each of our two roots we can convert into our x-intercepts. So that's how we would find 2 points that would actually fit on this graph. And also, once we get it into this factored form right here, I'm going to go ahead and write out y equals, and then our two factors x minus 4 and x plus 2. That would be, once again, what we call factored form. We also call it intercept form. And the reason why is it gives us the x-intercepts. The second thing that you need to know is knowing the x-intercepts is not enough to actually give us the equation that we're looking for that fits those x-intercepts. So if you look at the graph here, I've got 3 different parabolas showing here, and each of them does have an x-intercept of negative 2 and positive 4. And you'll notice here in every single equation over here on the left, there's x plus 2 and x minus 4. And the difference is this number, this multiplier out in front. One of them is a 1, one's a 0.5, and one's a negative 2. And that will actually give us a different parabola or quadratic that goes through those x-intercepts. So what we're going to need is we're going to need a third point that's unique to that particular parabola. For instance, this has a y-intercept of 16. Over here, this one has, the red one has a negative 4 as our y-intercept, whereas the blue one actually has a y-intercept of negative 8. So we could use that unique point to that parabola to actually help us figure out what this multiplier is that will go in front of our two factors. As always, if you like what you see, please like, comment, or subscribe. Thank you, and now back to part 2. And that leads us now to actually how to use this method here. So what we're going to do is we're going to look at the points we're given, and we're going to identify our x-intercept. So one of them is negative 1, 0, and the other one is 3, 0. So from here, I can write out 2 sets of parentheses. One of them, if the x-intercept is negative 1, I'm going to have x plus 1. And the other one, if it's going to be 3, it's going to be x minus 3. And the reason why is those values of x will make either parentheses equal to 0. So the negative 1 makes this one equal to 0, same thing here. And now what we need to do is we need to find out the multiplier. So what we're going to do is we're going to call that multiplier A. And now we're so close to the actual equation if only we knew the multiplier A. And the secret is we have to decide right now which of the other points we're going to use. So there's only 2 other points given to you. One is 0, negative 12, and one is 5, 72. It really doesn't matter which one you pick. Typically, if I'm given the y-intercept where x is 0 and negative 12, I'm going to go ahead and pick that. So we are going to actually use that point of 0, comma, negative 12. And by using that point, we can go to this equation over here and we can replace every single x with 0 and every single y with negative 12, because that's the point we're using. So I'm going to go ahead now and replace that y with negative 12. A we're going to leave alone. And if I plug in a 0 for x, I'm going to get 0 plus 1. And over on the other one, I'm going to get 0 minus 3. And of course, you know that if you take 0 plus 1, that will be just 1. And 0 minus 3 is negative 3. Negative 3 times 1 is negative 3. So we get negative 12 equals negative 3a. And if we go ahead here and divide by -3, we will get the answer of -12 divided by -3 is 4. So A is 4. And so what that means is our actual equation is going to be y equals the quantity 4 times the quantity x plus 1 and times the quantity x minus 3. So that would be our equation. And as far as I'm concerned, you can go ahead and you can leave it in what we call intercept form. Your teacher may ask you to put it into standard form, and all you need to do then is take x plus 1 times x minus 3 and then figure out that answer and then multiply everything by 4. But, really honestly, you're fine here leaving it in intercept form. So I hope you got a lot out of this video and hope to see you again soon. Thanks for watching.